Hey, hi guys, welcome. So this is the part of DevOps interview preparation series. So today let's discuss about Kubernetes interview preparation. Okay, so we will be covering all the major scenarios and issues and the questions which can be asked and the answers for those things. Okay, so let's discuss the first scenario. So the application parts are stuck in crash loop backup. Okay. So the scenario is the application parts repeatedly restart. Okay. So we will have a list of parts and they are repeatedly restarting due to some misconfiguration or some runtime errors. So how we will troubleshoot those things? So the first step is to check the pod logs. Okay, we have to check the pod logs using kubectl logs. Okay, so that we will get an idea like what exactly is the error, and then we can inspect it. Okay, we can do kubectl describe pod so that we will get the resource configurations, those things, and then we can do kubectl get pods, and then you can give the pod name slash o YAML so that you will get the YAML file, and then you can check the configurations which you have defined. So in case if you find something different or something is having issue, then you can update the YAML file and then you can fix it by applying the YAML file again. Okay, kubectl apply -f and then deployment name.yaml. Okay, so um, logs will always show. For example, in case if we have some environment variables or incorrect database credentials or some other errors, we will be able to fix that one. Okay, so we have seen some issues like the database URL is not properly saved, so that it was throwing error. Okay, so similarly, in case if some there is some missing configurations, then obviously you will see these errors related to crash loopback. Okay. So the next question is node not ready. Okay. So previously we have seen that pod is having crash loopback, but here the node, the server itself, it is in the not ready state. Okay. So scenario is a cluster node is in not ready state, disrupting workloads. So in case if you are trying to create any of the parts or any of the services, then it is not able to create those resources. Why? Because node is in not ready state. Okay. So you have to do kubectl describe node. Okay. Because you're checking node, right? So node and then node name. Node name is like whatever the name you have given for the node, worker node. You can just give that one. And in case if you have to check the logs of kubelet, okay, kubelet is one of the key configurations in the worker nodes. So in case if you have to check logs of kubelet, then you can do journalctl -u kubelet. Okay, so that you will be able to see the errors in log. In case if something is missing, you can fix using that one. And verify disk and memory usage. Okay, so you are trying to deploy a Kubernetes pod, but it is not deploying in the node, or else the node is in not ready state. So you can check the memory and the CPU using top command. Even in Linux, you will use top command to check the memory usages and all. So you can use kubectl top node and then you can give the node name. Okay. And then one more thing is drain the node and restart the service. So for example, if you are having certain parts deployed in the node, you can drain that one. Okay. Using kubectl drain and then node name and then ignore daemon sets. Daemon sets we have to ignore because daemon set parts it is for enabling monitoring, so we can ignore that one. And then hyphen force will force the drain to happen immediately. Okay, and then to restart the kubelet, so sudo systemctl restart kubelet. Okay, so mostly the issues will be resolved by cleaning up disk space, or else some other things. So based on these troubleshooting steps, you will be able to troubleshoot those things. Okay. And third question is persistent volume. So we know what is persistent volume. So it is mainly used for as a backup for the data. So it is in the pending state. So persistent volume will be created, and then persistent volume claim will be applied to the containers which are in the Kubernetes cluster. So the scenario is persistent volume claim fails to bind to the persistent volume. So persistent volume is there, and using persistent volume we will be creating persistent volume claim. Okay, so persistent volume claim fails to bind with persistent volume. Okay, so what you can do kubectl describe pvc and then pvc name. Okay, and then you can do kubectl get pv to list the available persistent volumes, and then these pvs persistent volumes will be created using storage class. Okay, so you have to see the storage class as well. kubectl get storage class, or you can use kubectl get sc. So both will work. So you can check the storage of storage class, and then update the PVC to use correct storage class. For example, you are using PVC, and if you have defined wrong storage class, then it will not work. So check for the storage class name as well. Okay. So in case if you update the configuration correctly, it would work. Okay. So the next question is service unable to route traffic to the pods. Okay. So how the things communicate? So in case if we have to enable the communication between different pods, or else from the outside world, all the traffic goes from service to the pods. Okay. So what is the scenario? A Kubernetes service is unable to forward traffic to its backend pods. Okay. So the traffic is hitting the services, but it is not able to forward it to the backend pods. Okay. So first we have to verify the endpoint. Okay, endpoint is present or not in the service. How we can verify? Kubectl get endpoints. Okay, and then you have to give the service name. Okay, how do we get service name? Your kubectl get svc service. Okay, so we will get the service. So the service which is having error, we can just point it here, and then ensure pod labels match service selector. Okay, so the pods which are in the backend, it has to point correctly to the service. So you have to check the labels as well. So kubectl get pods -f show labels. So these labels should match to the service. Okay, and then to debug internal connectivity, you can kubectl exec. You can exec into the pod, and then use the curl. You can give the service name and port name, and you should check whether it is able to communicate with that port. Okay. So actually the mismatch between part labels and service selectors can cause this issue. So fixing those things and assigning it properly will be helping in troubleshooting that issue. Okay. And then next scenarios, high pod evacuation and cluster. Pod evacuation means parts are not able to be deployed, or else the parts are getting drained. Okay. So the parts are frequently evacuated due to high resource pressure on nodes. So parts are automatically getting deleted or drained out on the nodes. Okay. So analyze the node resource usage. So using kubectl top nodes. Okay, when you do kubectl top nodes, you will get the memory and CPU utilization, and then you can do kubectl describe node. Okay, when you describe, actually you will get to know the issue or any issue with the configurations, and then adjust pod priorities to protect critical workloads. So for example, you are having a node and there is some critical application. No matter what, that part shouldn't be evacuated. Then actually you can set the priority class. Okay, so when you set this priority class name as high priority, then the parts which are of low priority, it will be evacuated. Okay, and meanwhile what you can do, you can scale up the cluster. Okay, you can scale the nodes, number of nodes, and then you can increase the replicas as well, so that even when high load comes, it will be able to distribute the load. Okay. So evacuation will caused due to memory pressure. Adding additional nodes to the cluster and using pod priorities can be mitigated, can mitigate the issue. Okay. So always try to check what is the exact issue using kubectl top nodes, and then describe to find the actual issue. And then you can set up priority class so that the critical application doesn't exit. And then you can scale the nodes. Okay. By scaling the nodes, you will be adding additional memory and CPU for that application so that it can run smoothly. So the next question is liveliness and readiness probes are failing. Okay, liveliness and readiness probes are so critical because in case if particular pod is getting deployed, then actually it has to be ready to accept the traffic. Otherwise, data loss will happen. Okay, so what is the scenario? Pod fails health checks, resulting in restart or unavailability. So pod is continuously failing, so that the pod is means parts fails the health check. So health check is not properly configured, and it is causing the restarts. Okay, so what you have to do, debug the probe endpoints. So you can exec into the pod, and then you can curl using localhost, and then port of that particular application, and probe path. For example, it will be defined in certain path. Okay, these health checks, so you have to check that path. Okay, if you see, so actually it will always, the health check will happen for a certain path. So if you see here, they have configured the liveliness probe at what path? At temp healthy. Okay, so this is the path. So this is the path which we have to place here. Okay, probe path. and then port number. In case if we have some endpoint with port number, we have to point to that port number as well. So if you see here slash health, this is the path and port number is 8080. So here port number should be 8080 and path should be slash health. Okay, so when you curl that one, actually you should get response. In case of any errors, it will fail. Okay, so by that you will know. Okay, anyway we have the example here itself. So adjust the probe configuration. So path and port has to be configured properly, and then kubectl rollout restart. So in case if it is like a temporary issue or whatever, so or else once you fix the issue, you have to do the rolling restart. Rolling restart means it will restart one pod at a time, so that there will not be any downtime. Okay. Okay, next question. So HPA not scaling parts. Okay, horizontal pod accelerator autoscaler doesn't scale workloads as expected. Okay, so if you see, actually you can do kubectl describe HPA and then you have to provide the HPA name. Okay, so that you will get to know the basic information about the configurations and errors, and then you have to verify the part resource request limits. Okay, whether the request the limit will be always maximum. This is the maximum thing which is assigned, and request is the one which is assigned to the application. So you have to verify the uh, requests and limits are set properly. Then you have to check the metrics like how is the CPU and memory utilization using kubectl top part, and then you can do the rolling restart of the deployment. Okay, so you will be able to find the exact issue, and you will be able to fix that one. Okay, so normally like the configuration like minimum and maximum number of parts configuration which is set up in the HPA, you have to check like whether it is properly configured. Okay, so one of the issues we faced are like HPA was not scaling due to missing resource limits. Okay, so these resource limits were not properly configured. Because of that, HPA is failing. So after making the necessary changes, we fixed that issue. Okay, config map changes not applied. Okay, so updates to config maps. So we have made some updates to the config maps, but it is not reflecting in the parts. For example, you are trying to update a database URL. You have updated the config map and you have applied it, but it is not reflecting in the pod. So what could be the issue? So you should do kubectl get config map, and then you have to give the config map slash o yaml, so that you will get the yaml file and you can check whether it is updated or not. So in case if it is updated but still it is not reflecting, then you have to do rolling restart. Okay, you shouldn't do it all, means you shouldn't delete all the parts at once. You have to roll out in a manner like it should be deleting only one part, or you should set criteria. For example, if 10 parts are there, you should set criteria like 25% of the parts should restart. Okay, so that like only 2 or 3 parts gets deleted at a time, so that the application will be up all the time. Okay, so once we check this one, and if it is properly updated, doing rolling restart will automatically fix the issue. Okay, DNS issue in Kubernetes cluster. So, okay, the parts are unable to resolve the service name because services will always be having the domain name. Okay, because even if we restart and if the parts are assigned, and if we are not using DNS, the IP addresses may change. Okay, so that the communication disruptions may happen. So always we use DNS. Okay, so in case if parts are unable to resolve the service name, what we can do? So check the core DNS pod. Okay, we will have one pod called as core DNS. You can check this as well in your system or in Kubernetes cluster. So this will be in kube system, in the namespace of kube system. Kube system is default namespace, like it will be coming by default in the Kubernetes cluster. Okay, so that core DNS, it will be deployed in the kube system namespace. So you do kubectl get pods hyphen n kube system, and then Kubernetes app equal to kube DNS. Okay, so this will list all the parts which are with kube DNS, so that you can check whether it is running properly or not. In case if it is failed, then you can restart, or you can try to check the what is the exact error, and you will be able to troubleshoot. Okay, so and then we can validate a DN functionality inside the pod. So you can just exec it into the pod, and then you can do ns lookup. So ns lookup is also the Linux command. It is just for looking up the domain names. Okay, so you will get to know like whether it is working properly or not, or else you can do kubectl describe config map and then core DNS. So config map name will be core DNS related to this DNS in the namespace of kube system, so that we will have the um, proper error, so that you will be able to troubleshoot. Okay. So parts stuck in container creating. Okay. So we will have like a different errors in parts. So this is about a container creating state. So it will be stuck in a state like container creating. It is not crash loopback. It is like we will have another condition as well. It is like container creating. So pod remains in the container creating state and fails to start. Like it will not start, but it will be always showing as container creating. So what we have to do? We have to do the describe pod so that we can get the overview of configurations, and then we can do kubectl logs pod name, and then we can check the container. So in case if we have like more than one container, like init containers, most probably we will face issue in case if the init containers doesn't come up properly. So you can do -c and then see the container. For example, if you have two containers, you can check both the containers so that you will be able to see the logs of those init containers as well. And then we can check the node as well. So we can check how the memory and uh, CPU are allocated. In case if there is some resource constraints, then also we will be facing this issue. So, so what we can do, we can inspect the nodes, and then we will be able to check the errors. Or you can try to recreate the pods if necessary. Okay, you can try to delete the pod, and then you can try to reapply the pod config.yaml. Okay, so that you will be able to fix that one. Okay, so one of the scenarios which we faced, like image pull failures caused by missing credentials due to secret issue. So in case if the secret is not properly configured, then also you will face issue. So anyway, in the when you do logs, kubectl logs, you will get to know like what is the exact issue. Okay, like it will show like credentials is wrong, or secret is not created, whatever it is, then we will face this issue. Okay. So the next one is like Kubernetes cluster upgrade issue. Okay, a Kubernetes cluster upgrade causes an API server down. Okay, so normally all the communications like kubectl communications happens with the API, right? So in case if the API is down, then we will not be able to communicate with the cluster. Okay, so when we do the Kubernetes cluster upgrade, we have to update that as well, right? So what happened? So API server was down, and workload was imbalance. Okay, so what we have to do? First step when we do the Kubernetes cluster upgrade is backup the etcd data. So we have to take the backup of etcd. Etcd is the database for Kubernetes. It will have all the configurations. So how we can do? Just you can give the variable yes. Okay, this we have to give the etcd-ctl API equal to 3. So first we have to configure this one. This is the API version, and then we have a tool. The tool is etcd control, etcd-ctl. So etcd-ctl is nothing but control. Okay, etcd-ctl snapshot save. So snapshot save. So it will save the snapshot as snapshot.db of the endpoint. We have to give the endpoint URL colon 633 port number. So the default port number, so 6443. So this is the default port number of Kubernetes. Okay, so you can just give the endpoint IP address and URL, so that you will be able to take the snapshot. Then upgrade using kubadm. So sudo apt get update, sudo apt install -y kubadm. So you will be installing a kubadm, and then sudo kubadm upgrade apply, and then target version, like whatever version you want. Like currently it is 1.31, right? So whatever version you want, you can just upgrade. Okay, and then upgrade kubelet and kubectl. So when we do the Kubernetes cluster upgrade, we have to upgrade each and every component. Otherwise there will be misconfiguration and conflict of versions. Okay, and then we have to drain and upgrade nodes. So normally in nodes we will have some parts already there, right, running. So actually we have to drain the nodes. Okay, and then we have to upgrade, and then again uncordon the nodes. So when we uncordon it, again the parts which have been evacuated, it will come and get deployed in the nodes. Okay, overloaded API server. Okay, high API server load affects performance and causes timeouts. Okay, in case if there is a huge number of requests coming to the API server, because API server is the single source of like it is the path by which we will be able to communicate with the Kubernetes cluster. So in case if we get more number of requests on API server, so it will cause timeouts. Okay, so how we can fix those things? So check API server logs for excessive requests. Okay, so how we can check? Using kubectl logs -n kube system. Okay, so in kube system we will have a part for API server. Okay, so we can check the logs of that API server and identify frequent API user. So when we do kubectl top parts -n kube system, we will get to know the part which is like most used or most consumed. So and then we can enable client side caching. Okay, so what happens when we enable caching? It will not create the new requests always. Okay, in case if the particular data is frequently accessed, it will be saved in the cache and it will be served from this cache. Okay, so we have to enable this client side cache in kube proxy. Okay, how we can do? Kind is config map and then API version, and then we have to update it in kube proxy. Okay, so we have to update the cluster sider and mode is IP tables. So we can update this client side caching so that we will be able to handle that high traffic, and then add replicas of HA. Okay, so we can increase the replicas. For example, we can scale the deployment of a kube API server to 3. For example, if it has only 1 or 2 replicas, you can increase the replicas, or else you can increase to 6, 10, whatever you want, based on your application size and amount of traffic it has to handle. Okay, so that in case if it has more replicas, it can handle more requests. Okay, and then ingress not working. Okay, so in this scenario, an ingress resource fails to route external traffic to backend services. Okay, so the ingress is not routing external traffic, the traffic which is coming from outside world to the backend services. So how we can fix that one? So normally we have to describe the ingress resource. Okay, kubectl describe ingress and then ingress name. So how we get ingress? To get the list of ingresses, we have to do kubectl get ingress. So once we get and get the ingress list, and if we find the exact ingress, we can do kubectl describe ingress and then ingress name. Okay, and then we have to verify the backend service as well. So to get services, kubectl get svc, and to verify particular backend service, kubectl get svc and then service name. Okay, and then check ingress controller logs. So we can check the logs like kubectl logs and then ingress controller pod. Like in case if you are deployed in ingress namespace, you just give the -n and then ingress namespace name, and then you will be able to check the logs. Okay, also we can test the DNS. Okay, we can do ns lookup and then ingress host name, so that we should see the output, otherwise it will throw error. Okay, and the next question is, part scheduling fails despite node availability. Okay, node is available, but again part is not scheduling. Okay, so the scenario is parts are not scheduled on available nodes due to constraints like taints, tolerance, or affinity rules. Okay, so in case if you have applied any of the taints and tolerations to the nodes, then obviously we will not be able to place the parts. Okay, so we have to make that part as tolerant to that taint which we have applied on the node, or else we have to define the affinity rules properly. So what we have to do? We have to describe the pod so that we will get to know like why it is failing. Okay, and then describe node, the node on which we are trying to place. Okay, and then add tolerance. So we have to add tolerance to the taints which we added in the nodes. These tolerations should be always applied to pod. Okay, taints has to be updated to nodes. Okay, so toleration should be something like whatever key we have given and then operator exists and then affect no schedule. Okay, or else in case if you have applied any affinity rule, you have to check the affinity rule like a node affinity required during schedule and ignored during execution. Okay, and then that expression should match. Okay, by checking these things you will be able to fix that one. Stateful parts failing after restart. Okay, so after restarting stateful parts, data or application state is missing. Okay, what are stateful applications? So stateful applications are like databases or something which will have the data synced between each and every part. Okay, and the even the names of that parts will be in a linear manner, like 0 1 2 or whatever it is, so that even when we restart the part name, it will be like same, like we will not get different names. Okay, so how we can troubleshoot that one? So you can check like persistent volume claim, whether persistent volume claim is properly assigned or not, And then you can check volume mounts in the parts. We will be mounting different volumes, right, for persistent data and all. So we have to check the mount paths in the pod. So kubectl describe pod, so that we will get the details, and validate the headless services. Okay, so we will have few headless services, so we can just do kubectl get a service, and then we can give the headless service name. Okay, so that we'll be able to check the logs as well, and then fix volumes and redeploy. In case if some issues with the volumes, then we can fix those things, and we can try to redeploy, so that the issues will be fixed. Okay, and then the next question is Kubernetes network policies blocking traffic. Okay, so the network policies unintentionally block traffic between parts. So we have parts, and then we have configured the network policies, like how the parts has to communicate. Okay, so unintentionally, it's like we don't want to block, but due to some misconfiguration, the traffic is blocked between parts. So how we can troubleshoot that one? So we have to describe the network policy. So kubectl describe network policy, and then policy name, so that we can check the policy which is applied, and then validate pod labels. Like we can check the labels whether we have configured the labels properly or not. In case if there is some misconfiguration, then actually the data might be going to some other parts which is not related to us. Okay, so we have to validate the labels as well, because the parts identify are grouped together based on the labels only. Okay, so we have to check whether the labels are properly configured, and then test connectivity. So we can always exec into the pod which is having issue, and then we can do curl to the target IP address, so that we will get to know like what is the exact issue. Okay, and we can update the network policy in case if the issue is with any of the labels and all. We can just update the policy, so that the issue will be fixed. Okay, so the next scenario is part stuck in terminating state. Okay, previously we have seen crash loopback, and then we have seen container creating. This time parts are in terminating state. Okay, but they are not terminating, it is stuck. Okay, it is showing as terminating, but it is like that. Okay, parts remain in the terminating state even after multiple delete attempts. You are trying to delete it, but you are not able to delete. It is stuck in the terminating state. So what you can do? You can do force delete. Okay, how to do force delete? Kubectl delete part name, grace period equal to 0. Okay, when you give hyphen hyphen grace period equal to 0 and hyphen hyphen force, it will try to delete the part forcefully. Okay, and then check if finalizers block deletion. We have something called finalizers, so in the configuration, so we have to check whether it is blocking deletion. So how we can get kubectl get pod hyphen o json, and then jq is nothing but java query, json query. So when we query dot metadata finalizers, so this metadata will be configured in these finalizers will be configured under metadata. Okay, so under metadata we will have finalizers, and then in case if we have to remove the finalizers. So how to remove? We have to do the patching. Okay, kubectl patch pod name hyphen p is with path, and then metadata, and then finalizers. So what we are doing, we are emptying it, and then hyphen type equal to merge. So it will like patch that particular part, and then when you do kubectl delete part again, it will delete. Okay, and then cluster autoscaler not scaling nodes. So in what is the use of autoscaler? Autoscaler will automatically increase the number of nodes in case if there it reaches certain criteria, like CPU or memory utilization greater than 80 or 85%. So whatever criteria we have set, so it will automatically try to scale the nodes. Okay, that is the use of autoscaler. Here what happens, cluster autoscaler fails to add additional nodes. Okay, during high workload demand. So we will be configuring this autoscaler in such a way it will always like maintain minimum number of nodes. In case if the criteria reaches certain range, it will increase the number of nodes. Okay, but it is failing to increase the nodes. Okay, what is the issue? Inspect autoscaler logs. Okay, you can do kubectl logs hyphen n cube system. Okay guys, I have told you guys multiple times about this namespace cube system. You can try to check the parts which are in the cube system. Okay, those are like very important for smooth cluster operation. Okay, so you can do kubectl logs hyphen n, and then deployment cluster autoscaler. So this autoscaler cluster um, configuration file will be under this cube system. Okay, it will be deployed as a deployment. Okay, so you can check whether it is properly configured, and then verify the resource requests. So requests and limits. So limit is the thing like a maximum we can allocate, and requests are done by parts. Okay, so you can request, you can check like requests are properly configured. In case if you want, you can increase the CPU and memory, and then you can increase the scaling limits. Okay, you can kubectl describe config map, and then this config map will have the configurations of this cluster autoscaler. Okay, and you can check whether it is properly configured and adjust the group size. Okay, so in case if you are using AWS, you can use AWS autoscaling, set decide capacity, and then autoscaling group. So when you do this autoscaling, it will be configured as a group. Okay, so we will be defining like minimum and a maximum number of nodes as well, just like HPA. Okay, and then decide capacity, like a new size you can give. Okay, metric server failing in custom cluster. Okay, what is metric server? Metric servers are like for monitoring and for logging our clusters. Okay, so metric server fails to provide pod and node metrics in self-managed cluster. So they're trying to check the pod and node details like CPU, RAM utilization and all, but it is not providing them any information. So what could be the issue? So inspect metric server logs. Okay, kubectl logs -n kube system, and then deployment metric server. Okay, so you can check the metric server deployment so that you will get the issue, and then verify kubelet arguments. Okay, you have to check whether kubelet is working fine or not. Okay, and then update the metric server deployment. So in case if there is some issue with any of the things, you can just update the metrics, like under the spec of container you can give the arguments as kubelet insecure TLS. So in case if it has some TLS issue or something, you can update this one so that you will be able to fix. Okay, so the first thing is you have to check the metric server logs so that you will get to know what is exactly is the issue, and then you have to check the kubelet. Okay, kubelet arguments, whether the it is properly assigned, and then in case if there is some issue with the arguments, you can update it properly. Okay, so the next question is parts running on unintended nodes. Okay, so you want your parts to be running on particular node. For example, you have to deploy your application on node A, but the parts went and deployed on node B as well. Okay, so what is the scenario? Parts are scheduled on nodes that do not meet application requirements. Okay, you don't want the parts to be running on certain node, but it is going and deploying in that particular node. So what you can do, you can verify node labels, because why it will go and deploy in other nodes? You might be configuring the labels wrongly. Okay, you can check whether the labels are properly configured, like kubectl get nodes show labels, so that you will get the labels, and then update the part affinity. Okay, you can update the parts with proper labels. Okay, node selectors as whatever this is, like just for example, you can define whatever it is, like app equal to prod dev, whatever you want. Based on the node, you can update these affinity rules, and drain the unintended nodes. For example, if you you want to deploy it on node A, but it has deployed in node B, now you have to move all the parts to node A. Then what you can do, you can drain the node. Okay, when you drain the node, and you have to always ignore daemon set, because that is for monitoring. When you do that one, it will in case if you have only two nodes, from B node it will go to node A, then you can do the rolling restart of the deployment, so that you will be able to fix the issue. Okay, yeah guys, that's it for now. So actually we have covered most of the topics which are important when it comes to Kubernetes. Okay, by preparing this, you will be able to answer any question the interviewer asks. Hope this is helpful. Guys, if you like the video, please like and subscribe to the channel. That will be helpful. Okay, thank you very much, guys. So we will continue this series for all the tools of Kubernetes, so that it will be helpful for everyone. Okay, thank you. Bye.